Hello friends, continuing with the topic of electric flux, today we take up Gauss law or Gauss theorem. What is the statement? Let us see. Total outward electric flux linked with any closed surface is equal to 1 by epsilon 0 times the net charge contained in a volume enclosed by the surface. I repeat, total outward electric flux linked with any closed surface is equal to 1 by epsilon 0 times the net charge contained in a volume enclosed by the surface. Now, mathematical statement. How we give mathematical statement? Surface integral of electric field over closed surface is equal to 1 by epsilon 0 times the net charge contained in a volume enclosed by the surface. I repeat, surface integral of electric field over closed surface is equal to 1 by epsilon 0 times the net charge contained in the volume enclosed by the surface. Mathematically, it is expressed as sign of integration over closed surface E vector dot ds vector is equal to 1 by epsilon 0 times QEN, charge enclosed. So this is how we mathematically express the Gauss law. Surface integral of electric field over closed surface is equal to 1 by epsilon 0 times the charge enclosed. Now look at the diagram. This is any closed surface S. It encloses charge Qn. Then flux linked will be equal to 1 by epsilon 0 times charge enclosed, and it is also equal to sign of integration over whole surface E dot ds. So we equate the two terms, and then because the two terms represent the same physical quantity, electric flux, and this expression gives us the statement of Gauss theorem or Gauss law. Now, proof of Gauss law. A part, physical situation. We develop physical situation. Consider a point electric charge plus Q inside a closed surface S at any point X as shown in diagram. Let P be any point on the surface S at a distance r from the charge such that electric field at P is given by the expression E is equal to K naught Q by R square and along Py. Direction is along Py. Let us mark it as equation 1. Now B part. Small flux linked with surface ds. Consider a small surface element ds of the surface S such that point P lies on it and is along Pz. Along Pz means the area vector, direction of area vector is along Pz, and it is perpendicular to the surface ds, forming an angle YPZ at P. Now small flux linked with the small surface ds will be d phi e equal to E dot ds, or d phi e is equal to mod E mod ds cos theta. Let us mark it as equation 2. Now substituting the value of E from equation 1 in equation 2, we get d phi E is equal to K naught Q by R square into ds cos theta, or it is equal to K naught Q ds cos theta by R square, or it is equal to K naught Q into d omega, where d omega is equal to ds cos theta by R square and is known as solid angle. So this is solid angle. You look into the diagram. Okay, so where d omega is equal to ds cos theta by R square and is known as solid angle. Now C part. Total electric flux linked with the whole surface. How we calculate? Let us see. Total electric flux linked with the whole surface can be obtained by integrating equation 3 over whole surface. So we integrate equation 3 over whole surface. So integration over whole surface d phi e on left hand side, it is equal to integration k naught q d omega over whole surface on right hand side, and it is equal to k naught q integration d omega over whole surface, and it is equal to k naught q into 4 pi, because integration d omega over whole surface is equal to 4 pi. So because solid angle for any closed surface is always 4 pi. So we replace integration d omega as 4 pi. So finally, therefore we get phi e is equal to k naught q into 4 pi, or it is equal to 1 by 4 pi epsilon naught q into 4 pi. So we replace k naught by 1 by 4 pi epsilon naught, and 4 pi cancels, and we are left with 1 by epsilon 0 into q. Hence phi e is equal to 1 by epsilon 0 times the q, where q is the charge enclosed by the closed surface. Let us mark it as equation 4. Now we come to discussion. So when charge enclosed is 0, then flux enclosed will be 0. Okay, because 0 divided by epsilon naught will be 0. Now second case, when closed surface encloses equal and opposite charges, then again flux is 0, because when a closed surface encloses equal and opposite charges, so net charge enclosed by the surface would be 0, because charge are additive, and when positive and negative equal charges add up, they result into 0 charge. So net charge would be 0, which is enclosed by the surface. Hence electric flux would also be 0. The third case, when charge lies outside closed surface, then again electric flux is 0, because the closed surface does not enclose any charge, which is the requirement of Gauss law. Now assignment 1.5 continued. Question number 9. A point charge of 10 raised to power 7 coulomb is situated at the center of the cube of 1 meter side. Calculate electric flux through surface of the cube. Question number 10. A point charge of plus 10 microcoulomb is at a distance 5 centimeter directly above the center of the sphere of side 10 centimeter, as shown in diagram. What is the magnitude of electric flux through the sphere? So this is the answer. You solve this numerical problem on the basis of the text that you have learned. Assignment 1.5 continued. Question number 11. Figure shows a hypothetical cylinder of radius r immersed in a uniform electric field of strength E. The cylinder axis being parallel to the field. Calculate electric flux linked with the cylinder. Now here electric flux linked with the cylinder would be 0, because the cylinder does not enclose any charge. Charge lies outside the cylinder as per the electric field shown. Okay. Assignment 1.5 continued. Question number 12. A student is asked to calculate ratio of electric flux through the surfaces of spheres S1 and S2 with charges placed inside as shown. He gets the answer as 4:1. Check the correctness of the answer by actually calculating the electric flux ratio through the two surfaces and whether his answer is correct or incorrect. So you calculate electric flux through the two surfaces and then verify whether his answer is correct or incorrect. Okay. Assignment 1.5 continued. Question number 13. Electric field in the figure shown is directed along positive x direction and given by Ex is equal to 5ax plus 2b, where E is in Newton per coulomb and x is in meters. A and B are constants with dimensions talking A equal to 10 Newton per coulomb per meter and B equal to 5 Newton per Coulomb. Calculate number 1 the electric flux through the cube, number 2 net charge enclosed within the cube. Okay. Thank you so much for listening patiently and try to understand. I hope you would have understood the proof of Gauss theorem and you apply Gauss theorem to solve these numericals. Only then you will have better understanding. Otherwise it will become difficult for you to solve numericals and applications. So it is better here and now you solve these numericals. Thank you so much. God bless you.